Welcome to your Chapter 6 practice test tutorial. First off, multiplying binomials. This can be done either using the FOIL method or patterns, or you can use the box to multiply out. I'm going to use the FOIL method. That takes your first terms, multiply those together. That's the F part. X times x gives you x squared. The outside terms, that's your O for FOIL. X times 5 gives you 5x, so plus 5x inside, plus 2x, and the last terms, 2 times 5, which gives us 10. Next step I need to take is to combine my like terms, so that's 7x, drop down everything else I didn't use, so plus 10 and plus x squared, and that is my answer. So it's a matter of rewriting those binomials. X plus 6 squared is not x squared plus 36, so make sure you're very clear about that. The reason for that is this is x plus 6 times x plus 6. That's what it means to square something as we multiply it by itself. So we do the same thing as we did above. X times x is x squared plus 6x plus 6x plus 12. That is x squared plus 12x plus, not 12, I'm sorry, 6 times 6 is 36. My mistake. And plus 36. So this is my final answer on this one. This is what's called a perfect square trinomial, which we've talked about in other videos, but I'll briefly discuss. When something is squared like this, that middle term squared is your last term, or sorry, that second term is your last term, and the middle term is made up of these two multiplied together, which would give us 6x, and then multiplied by 2, which would give us 12x. This helps us a lot in factoring in Chapter 7, if we know that perfect square trinomial pattern. The next one will lead us to what's called the difference of squares, also will help us in Chapter 7. If we have the same terms, but one is positive and one is negative, when we're multiplying these out, 2x times 2x is 4x squared, because I multiply the 2 times 2 and then the x squared. 2x times negative 1 is negative 2x. 1 times 2x is a positive 2x. And 1 times negative 1 is negative 1. These two add out to 0. Negative 2x plus 2x gives me 0, so this is 4x squared minus 1. So we call this the difference of squares because one we're multiplying, hence the difference part. And then 4x squared is the perfect square of 2x, and 1 is the perfect square of 1 times 1. So that is the multiplying binomials. And that in the gradebook is listed as Chapter 6A. That's the first part we're testing there. Second part, sorry for that, is testing your ability to multiply. So using some of those multiplication, the products to power rules, product rule, and I think that's it. Yeah, that's it. So on this one, it's important that you recognize that if all we're doing is multiplying and there's no exponents outside those parentheses, this can be rewritten as 2 times 5 times x squared times x to the 4th. You don't have to do that if you can see it, but in case you're wondering why this works. So 2 times 5 is 10, x to the 2nd times x to the 4th is x to the 6th. We add those exponents, and if you are unaware of why that works, then you need to see the BA6 exponent law summary video. But this is your final answer, 10x to the 6th. Second part is using the product rule, products to power rule. So this 2x to the 3rd means that we are doing 2x to the 3rd and then to the 2nd. That third power has nothing to do with that 2. So what I do is take 2 to the 2nd power, because that is in the parentheses and being taken to the 2nd power. And then x to the 3rd also to the second power. And this is my power rule. X to the third to the second is x to the sixth. Again, see that previous video. And then 2 to the second is 4. So 4x to the sixth on that one. Next up, I just need to take a couple extra steps here. I'm going to drop down this 3x to the third and lose the parentheses on it. On this one, 6x to the second, this is all in parentheses. So 6 to the second is 36. X to the second is x to the second. 3 times 36 is something I can't think of off the top of my head. Hang on. 108. So this would be 108. And then x to the third times x to the second is x to the fifth. I'm only doing the proficiency level. If you guys want to go for the highly proficient, I'm going to let you guys handle that. Alright, so that is part B. Part C has to do mostly with dividing these polynomials, the quotient rule. X to the ninth over x to the third, we subtract those. 9 minus 3 is x to the sixth. Once again, if you don't know why that works, see the previous video. 10 over 2, I'm rewriting this, separating my x's, my y's, and my constants. X to the sixth over x to the third times y to the second over y. And I'm going to go ahead and put the first because y is just y to the first. And then I'm going to go ahead and reduce these. Now, I didn't have to take this step. That's more for your benefit. 10 divided by 2 is 5. X to the 6 over x to the third. We subtract those exponents, so that's x to the third. And then y to the second over y to the first is just y. And that's my answer on that one. Oh, that's my answer on the first one. And then the last one, 6 over 18 times x to the fourth over x to the third times y to the ninth over y to the fifth. 6 over 18, that's going to give me a decimal, and it's not going to give me a nice decimal, so I just want to reduce that fraction. So that's going to be 1/3, because both 6 and 18 are divisible by 6. So this reduces to 1/3. X to the fourth over x to the third is just x, or x to the first. And y to the ninth over y to the fifth is y to the fourth. Something I need to recognize with these, whenever they reduce like this, they need to stay on the top of that fraction. So the way that I would write this is x, y to the fourth, all over 3. That one's a bit trickier. That was dividing polynomials. 0 exponents. We need to pay close attention to what is being raised to the 0 power and treat it differently. So anything to the 0 power is 1. This is all in parentheses. So this whole thing in parentheses, I'm going to go ahead and make it a circle. The only thing outside of it is the 0 power. So if there's nothing else outside of it, this is just 1. Here, the only thing being raised to the 0 power is the x. The negative, oh sorry, that's really small. I'm going to zoom in a little bit. So the only thing being raised to the 0 power is the actual x. The negative is going to stay outside of that, which means that the x to the 0 is going to give us 1, but I'm dropping down that negative. If, I just want to make sure this is really clear, if this was negative x to the 0 power, that would be different. That would be negative x being taken to the 0 power, which would give me 1. But because there are no parentheses, it's just the x going to the 0 power. So then part C, once again, I'm going to take those parentheses and turn them into a circle around the part being raised to the 0 power. So 5x to the 6 is being raised to the 0 power, so that is 1. What I'm left with out here is that 2. 2 times 1 is just 2. So that is 0 exponents. And finally, last part is negative exponents. So, negative exponents, remember that's what moves it. If it's a negative exponent, you need to either move it from the bottom to the top, or, sorry, Cord moved it there, or the top to the bottom. Several of these are multi-step. So I'm going to start by multiplying my exponents due to the power rule. So this would be x to the negative 12th, so these two, and then y to the 20th. So what I'm going to do is make this a fraction. I'm going to move that to the bottom of it. So when I write this, this is going to be y to the 20th over x to the 12th. And I can't reduce that any further because these don't have the same base. So that is my answer. Simplifying means that you have no negative exponents, so you need to make sure to move those around if they need to be moved. On part B, I have a negative exponent on both the top and the bottom. What I'm going to do is take this one, move it to, actually, I can change this. There's a couple things I can do here. I could do that. I could move that to the top, x to the second, move that to the bottom, x to the third. This would be x to the negative 1, which would be 1 over x. That is one way to go, probably not the quickest way to go. The other thing I can do here is subtract my exponents, so you have to just be careful with the negatives here. So this would be negative 3 minus a negative 2, which we now know is the same as negative 3 plus 2. So that would be x to the negative 1, which would once again be 1 over x. So that's another way around it. This, again, these steps being shown, that's kind of for your benefit. Alrighty. On the last one, I'm going to go ahead and simplify inside of my parentheses, keep that all to the negative second, and then go from there. So 4 divided by 2 is 2. X to the third over x to the second is just x. Keep that in parentheses, put that to the negative 2. Then I'm going to use the negative 2 to make that a fraction. So 1 over 2x to the second. So that move from here to here made that exponent positive. And then I've got one more step because I got to simplify this further. 1 over 2 to the second is 4, x to the second is x squared. So that is my final answer right there. And that is chapter 6 in a nutshell, what you needed to get out of it anyway. So if you have any further questions on this, please let me know, and make sure that you are prepping if you have to retake this test. Prep well, please. Alrighty, have a lovely day.